Hey all, welcome back to the episode 1 of Series A. In this episode, we are going to talk about semantic search with AI. And what exactly it is, let's deep dive into it. A traditional search matches the keywords, like if you say type hooks, and you get every article with the word hooks in it. But what if you type how component remembers things between renders? The keyword search returns nothing useful. An AI-powered search returns the article about useState, useref, or context API because it understands the meaning, not just the word. Today, we are building exactly this, a live semantic search bar in Next.js. You type, it hits an API route, that route embeds your query with the OpenAI embedding model, compares it against pre-embedded content, and returns the most relevant results, all in under 300 milliseconds. No database, no backend server, just Next.js. Here is the shape of what we are building, a React search input with a debounce on-change handler. On each keystroke, after a 300 millisecond debounce, we post a Next.js API search route. That route embeds the query using OpenAI's text embedding 3 small model, then calculates cosine similarity against a pre-embedded dataset. We store a JSON file. The top 3 matches come back as a JSON. The front end renders them. Let's dive deep into it. Now let's create an environment file. The most use that we're going to make out from the environment file is going to have an OpenAPI key. So just place your own OpenAPI key and we'll be good to go. Next, we need a package for the OpenAPI for performing the embedding. So just install the OpenAPI using the npm install OpenAPI command. Once it is installed, we are good to go. Let's create a new script named as Embed dataset. We use this dataset script to generate the search data. That search data will be our vector data that we'll be using with the API. Following to this, we are going to create two functions inside this. First, for the environment setup. Before anything runs, it manually loads env.local so OpenAPI key is available. It reads the environment local, pass the key value base, and processes to process.env. If the file is missing, it silently continues. The key might already be into the environment. Then it creates the second one, which is OpenAPI client. This is the core one who does the main job. Turns every article into a vectors, write it back to the search data. First, it embeds all articles, builds a short text, calls OpenAI embedding API, then returns the same article plus the embedding array. In a real application, you would run a one-time script that needs all your content, embed each piece, and writes the vector to a JSON file. Then use a pre-computed dataset so live demo works without waiting for an API call. Let's create a new route. This route implements semantic search. It turns the user's query into a vector, compresses it into the pre-computed article vectors, and then return the closest match by meaning. Firstly, let's talk about cosine similarity. So this function computes how similar two vectors are. It does three things. First, dot products measures the alignment between the vectors, then the norms, norms A and norms B, length of each vectors, then finally the ratio, which identifies the normalize so the length doesn't dominate. A number usually breaks between -1 and 1 as a result, where we often call it 0 to 1 for the embeddings, where 1 defines the direction is same, very similar meaning. 0 orthogonal, or we oftenly call it as unrelated, and -1 which entirely says it's an opposite direction or opposite meaning. While I write the post method or the post route for the search, let's talk about what is cosine similarity. So the cosine similarity embeddings map text to a point in a high dimensional space. Similar meaning vectors that point in a similar direction. Cosine similarity measures the angle between two vectors, not their distance from the origin. Why cosine? What exactly it does? It does embedding models turned into the direction encodes meaning multiple matterless. Cosine is scale invented. Multiplying a vector by a constant doesn't change the score. It's the standard metric for OpenAI style embedding search. It's cheap, one dot product and two norms per article. As an example, let's say a query how component renders things. Article understands the use state. Summary about remembering values between the renders. So keyword search might miss this. Cosine similarity on embedding can still rank this high because the vector aligns the meaning. Next, we have the post for the search handler. What exactly this function does? First, we parse the query from the JSON body using the query. Second, embed the query with the same model using the embed dataset. So query and article live into the same vector space. Third, we score every article with cosine similarity. Then sort by score, descending best matches first. Then we rank the top 3 of it. Finally, stripe embedding from the response. Large array, the client only needs the summary and the score, and then they return the JSON with the ranked results. Let's create a new page for the search. This page is going to contain the content about some static information about what exactly this AI semantic search is, and then the actual search inside it. As we're going to build this component, let's just comment it for now, and let's see how our initial new page for the search looks like. We just simply say we're going to have the search implemented here. Let's open it and see how it looks. Nice. So we have our page displaying some static content. Now let's build the actual AI search component. Let's create a new component called AI search. What this component does, it's a semantic search bar. The user types a question in plain English. We wait until they pause typing, call the endpoint, and shows the top matching articles with the similarity score. Let's create an interface or a type. So this is going to be a type of what the search result is going to contain. It's going to have an ID which will be unique for each search result. Then we are going to have a title and also the summary, what we show to the user actually. Then we are also going to have the slug and the score, where the score, how similar the article is to query between 0 to 1 from cosine similarity. Then we are going to export the AI search functions out of this component. What this component is going to contain? This component is going to have three main factors inside it. One is for the search input, where we input and find the query what user is looking for. Second, we are going to have the display results. So we are going to get, as you remember, we talked about the cosine similarity, and with the search API, we are going to get the top 3 results. So we are going to map over all the result information and going to have this display. And finally, we are going to have a section which will be a fallback section in case if we don't have the display results or the results coming for us, we are going to show the no results section. Then we are going to have the heart of the feature, which is use effect. So the use effect is going to contain the main logic about making the API call, getting the results. First, we'll create the search input section. So I am getting some predefined styles and the creation that I have. In this, we are going to add two information mainly. So it's going to be a search input, which we have the search icon, then we'll have the input section, and then we'll have the loader at the end. So the input is going to have the value and the onChange function. So whenever there is a change in the query, we invoke the function and the use effect is going to take the place. You can get the exact styles from the given repository. Let's now add the empty state section. In this section, we are simply going to check the query, and also when we are making the API call, if it is loading or not. If it is not loading and the display results.length is equal to 0, that means we don't have the display results. We simply shows there are no result to be displayed. So for the display results, if the box is empty, we treat results as empty, even if the old results are still in stale. It prevents showing the stale matches after clearing the input. Let's write the display results section. In this section, first we're going to check if we have the display results in the list. If we have the length greater than 0, we will display an unordered list. I'll simply get that from the existing piece with all the styles. You can copy it as well. Inside the unordered list, we are going to go over each display result and going to show the list within. You can copy the styling for this as well. Once we are done with that, we are going to start with the heart of this component, which is the use effect. In the use effect, first we check if there is a query within. If there is not, we simply returns out of it. Next, we create the asynchronous call to the search API. We write this within the set timeout. Why we do that? We don't want to search the query on every key press. So we wait for the 300 millisecond after the last change, which basically we call it as the debounce method. What exactly happens? Once we make a call to the fetch API, we set the loader spinner to true. So the spinner starts showing it. Post JSON happen. Then we get the set of the result. We store it to the results array. Then finally, we hide the spinner if something fails. At the end of the use effect, we clean up the time as well. So if the ISO types again before 300 millisecond, React runs cleanup and cancel the old timer. Only the latest query gets searched. Also, we add query as a dependency to the use effect. So every query change will make the use effect re-render. Let's go back to the search page and enable the AI search component that we disabled earlier. Once we enable it, let's go and give it a try and run it. Once we run it, we should be able to see the default page. Go back and redirect to the search component. You should be able to see the search component available to you and try to make the query. As you can see, let's say how the use effect work or an effect work. You will see use effect popping up at the top of the search result, or how to memoize thing, and you will see use memo and the other information as the top of the results. In the next episode, we are going to build and streaming autocomplete. And what exactly it does? Let's say I am going to visit and press the tab. The AI is going to give me the suggestion. Let's say hello and press tab. And it give me the suggestion what could be the potential sentences. So stay tuned and subscribe for the more content. Looking forward for it. Thank you.